All right, today we're studying annuity. Okay, let's look at what is annuity. Annuity is a set of regular equal payments over a set period of time. Okay, it's not just one time, two time, it's a regular equal payments over a period of time. So when to use what formula? Okay, we learned the compound interest in previous section. Okay, so compound interest only make one-time deposit. However, annuity, there's regular equal payments. So that's not just one-time deposit. It's a multiple either deposit or withdrawals. Okay, so based on whether it's equal multiple deposit or equal multiple withdrawals, and we have two different type of annuity. One is called a saving annuity, one is called a payout annuity. Okay, so for the saving annuity, you save the money now and then for the future usage. Okay, like you put the money in your retirement account. Okay, so every month you put maybe 500 in that IRA account. Okay, and then you're gonna do that for the next 30 or 35 years, and then you're gonna use it until you retire. You start to withdraw the money out. Okay, so you make multiple deposit. Okay, most often you do monthly. Okay, $500 every month for the next 35 years. And then this kind of annuity is called a saving annuity. All right, payout annuity is you already saved the money. Okay, now is the time you start to withdraw and use it. Okay, this kind of annuity, we call it payout annuity. So you're using currently. So you make multiple withdrawals, like a monthly, you're receiving maybe $1,200 from your retirement account. Okay, and then this kind of annuity called a payout annuity. So when you have a problem, you need to determine what type of annuity first. Why? Because it uses different formula. Okay, now let's look at one by one. So we look at a saving annuity first. Okay, saving annuity is annuity where deposits are made over time for use in the future. All right, this is the formula for saving annuity. And then what those parameter value means. Okay, FV, that means future value of the annuity. PMT, okay, that stands for payment, but in this setting, okay, PMT stands for monthly deposit amount. Okay, deposit amount, either monthly or quarterly or yearly, depends on your account. But that's the deposit amount, okay, regular deposit amount. R still interest rate is a percent number, okay? You need to convert to a decimal number when you do the calculation. K is the compounding period in a year, okay? If the interest compounding monthly, and then K equals 12. If interest compounding quarterly, K equals 4. Okay, quarterly. And then semi-annually, K equals 2. If it's annually, K equals 1. It's similar as a compound interest. Okay, there we use the N to represent in that formula, but here we use different letter to represent. Okay, and then N represent the number of years. Okay, now let's look at an example. A traditional individual retirement account, that's IRA, okay, is a special type of retirement account in which the money you invest is exempt from income taxes until you withdraw it. If you deposit $200 each month into an IRA earning 9% interest, how much would you have in the account after 25 years? And round your answer to the nearest cents. All the money amount, you always need to round it to the nearest cents because that's the smallest currency we have, right? All right, so now what type of problem this is? This is a saving annuity problem, right? And then what we're looking for, how much would you have in the account after 25 years? So we're looking for future value, isn't it? Okay, so we're looking for future value. Okay, and then the formula we have from the previous slide, future value equals, and then payment times, right, outer parentheses, inner parentheses, 1 plus r over k, close inner parentheses, raised to nk power minus 1, close outer parentheses. That's numerator, denominator r over k, right? And then we need to identify those 4 parameter values. What is the payment? Deposit value, right? Deposit amount. So we monthly deposit $200. Okay, so payment is $200. What is our interest rate? IRA account earning 9% interest. So that's 9%, which is equivalent to 0.09. K, how often the interest compounding? We're doing the monthly, right? Monthly. So K equals 12. N nth time in the unit of years, right? After 25 years, so N equals 25. So after we identify those parameter values, and then we plug into the formula, okay, which is 200 times outer parentheses, inner parentheses, 1 plus 0.09 divided by 12, close inner parentheses, and then raised to the power n times k power, that's 12 times 25, right? And then minus 1, close outer parentheses, that's numerator, denominator 0.09 over 12. And then we need to put this formula into our calculator. Okay, depends what kind of calculator you have. If you use the TI 8384 or their plus graphic calculator, okay, and I made a separate video to show you how to put in that calculator. If you use TI-30 XS calculator, you should have a fraction line, which is N over D button. Okay, you can use that to enter numerator, denominator separately. Okay, the rest is pretty much the same as using the graphic calculator. Okay, so see my next video. And then I already put into a calculator, and a calculator result is 224.39. Okay, the unit is the dollar. Okay, that's this example. And I'm using the TI-84 plus graphic calculator. Okay. The numerator, my numerator 200 times, and then outer parentheses, inner parentheses, 1 plus 0.09 divided by 12. Close inner parentheses, and then I want to raise the power. Okay, so raise to, and then power is 12 times 25. In my calculator, because when I raise to the exponents, and then my cursor is automatically raised, upper right corner. Okay, so if that is the case, I do not need to add a parenthesis around 12 times 25. Okay, but if your calculator, okay, is TI 83 or 84, not their plus, okay, and then your cursor will not automatically raise to the top. If that is the case, you need to add a parenthesis around 12 times 25. Okay, it's really, based on your calculator, whether you need to, add parentheses around or not, because my cursor already put in the exponential position, so that's automatically enforce the parentheses. In that case, I don't need to, add a parentheses. So now my cursor is on the exponential position. I need to bring it down to a normal position. So I need to use the arrow key to bring that down. Okay, so now you see my cursor is in the regular position, and then -1. And then I need to close the outer parentheses. Okay, so make sure when you enter the formula into calculator, all the parentheses need to be in pair. Okay, so this is the open parentheses, this one closed. Okay, this is open parentheses, this one close it. If your parentheses enter is not in pair, and the calculator will give you the error message. So this is my numerator, I'm done. Okay, now I enter denominator, which is divided by, okay, and then denominator 0.09 divided by 12, right? And then I need to put in the parentheses, okay, parentheses 0.09 divided by 12, and then close denominator parentheses, and then enter. Okay, that's the answer. But remember, this represents the monetary amount, right? So we need to round it off automatically with 2 decimals, which is rounded to the nearest cents. So we need to place the back door right here behind the 8. Okay, and then look at who is at the back door. 7. 7 is a number greater than 5. So we need to add 1 in this digit. So the answer should be $224.39, not 38 cents. Okay, 39 cents. Okay, and I hope that helps.